Okay, students, going over a few problems from this worksheet here, or just giving you some hints on them. For example, in 8 here, you might want to clear the decimal by multiplying each term by 10. Okay, that'd be a hint. Don't forget, solving all equations. Our goal is to isolate the variable, solve for one of those variables only. And the way to solve all equations, solve all equations by, and it'll work on this worksheet, but let me just give you the general idea first. If you had a bunch of, if you had parentheses and all that kind of stuff, so you had to do distributive property first and combine like terms, you would do all that first to clear the parentheses. We don't have it on this sheet here, but if you had that, you would do that first, and then you would do reverse PEMDAS. And you write it like this to make sure you go in the correct order. So you add or subtract, if there is any adding or subtracting first, and then you do multiplication and division after that, and then deal with exponents, and finally parentheses. If you look at this worksheet, there are no parentheses on it. Technically, when I look at 1718, another hint, if you ever have more than one term in a numerator or denominator, you want to put parentheses around it because this is grouped together as one thing. So you can't pretend like this is a plus 12 and I subtracted 12 across. That's one group. So if there's, in this case, they're both in the numerator. But if there's ever more than one term, remember terms are separated by plus or minus signs, either in the numerator or denominator. You need to put parentheses around it because that's one group. Okay. All right. So I'm going to do a couple. I'll do, let's do 14. Okay. 14, 15, or 13, or you could even do it from 9 to 18. Notice from 9 to 18, they all have a fraction in it. Okay, so what we want to do so that we don't have to deal with the fractions is we're going to clear the fractions. Not that you have to do it this way, but this is the way I teach it. Since a lot of students struggle with fractions, is we're going to clear the fractions from the entire equation. So that means we're going to multiply the entire equation. We're going to do 14 by the common denominator. So what's the common denominator between 3, 1, and 1? Obviously, it's 3. Okay, so we're going to multiply every term by 3. Distribute that 3 through there. When we do that, we get negative 36 equals 18 plus 2y. Remember, the 3's cancel right here. So you just have 2y right there. You're distributing through each term. If you need to draw arrows like this so you make sure you don't forget a term, go ahead and do that. Okay, so now notice we have no fractions left. We just do reverse PEMDAS. We're trying to get the y by itself. So I'm going to get rid of the 18 and the 2 to the other side. And of course, 2y, you know that means multiplication, 2 times y. So what is the opposite operation of times? Division. If you need to write division above it like that, because that's what you're going to do to get rid of that 2, go ahead and do that. This says plus 18. Remember, if there's no sign there, it's a plus. What's the opposite of plus? Minus. Okay, so now, not that you have to do that, but if you struggle with solving equations, this would be a good idea. Okay, so do we have any adding and subtracting? Yes, we do. We have a subtract 18 across right here. So we do that first. Reverse PEMDAS. So I'm left with 2y equals negative 54. And last step, I do my division. Divide by 2 on both sides. And y equals negative 27. And there's my answer. Okay. You could check that if you wanted to. I'm plugging it back in. We're not going to do that. I'm not going to do that, but you can if you want to guarantee you're right. I'm confident that I'm right. Okay, we will do one more. You can pause the video because I'm going to erase that right there. Make sure you have that down for 14, but I'm going to do 18 right there as well. So I'm going to erase this. Okay, so now 18. One more from the top group here. So all we have is we have a parentheses and we have division. Remember, reverse PEMDAS, we would get rid of division first. The opposite of division is multiplication. Okay, and then we have a parentheses to deal with afterwards. Okay, so we're going to multiply both sides by -4. That cancels out there, and whatever I do to one side, do the other side. So now I'm left with u plus 12 equals -20. Notice I took off the parentheses now because if I had those parentheses there, I only have a 1 out front. 1 times anything is itself. So I can go ahead and just drop those parentheses. And then I have my one last step of subtraction, -12 to both sides. And I get u equals -32. Again, you can plug that back in or substitute that back in, technical term, to check that you are right. All right, let me do one of these. I'll do 22. Notice you're talking about two consecutive, either odd or even integers. Okay, so you need to know the word consecutive. Consecutive means one after the other, no skipping. So if I were talking about consecutive odd integers, I could say 1, 3, 5, 7. I'm talking about consecutive even integers, 2, 4, 6, 8. Okay, right in order. So find two consecutive even integers. Well, if the first integer is x, how do I get to the next even integer? I add 2 to it. So like we just said, if I start with 2, the next one is 4. How do I get to 4? I add 2 to that previous term of 2. So there's my two consecutive even integers, and their sum. You gotta know sum means the answer to an addition problem. So I go ahead and add these together, and I get 2x plus 2. You need to know that is means equals in math all the time. 217. Subtract the 2 across, reverse PEMDAS. 215. All right. Two consecutive integers whose sum is 217. Let's see here. To find a very right equation and solve each problem, then check it. If I add any two even numbers together, I'm going to get an even. So this answer, this problem is a bad problem. It needs to be an even number. Okay, so you can scratch that. Another way to guarantee, I use x and x plus 2, but if I want to guarantee any to have an even number, I go 2 times x, because that way if x is odd or even, I double it, guarantee, whenever you double any number, you're going to get even. So the next one will be 2x plus 2. So let's try it this way. 4x plus 2 equals 217. Subtract 2 across, 215. And that's still going to give me a decimal. So that again proves this 217 is a bad problem right here. Okay, so scratch that one. It has to be an even number. When you add two even integers together, you're going to end up with an even, not an odd. If I take half of 217, that'd be 108.5. So if I went down to 108, the next one would be 110, and that would give me 218. Stay one off right there. Okay, and if I went down to 106 plus 108, that's 214. Okay, so you can't get that. It's got to be two consecutive even integers. Okay, so that can't happen. 24 is a bad one. All right, let's go ahead and do 21 here. Find three consecutive odd integers. So x, the next odd would be 2 more than that, and the next odd would be 2 more than the previous one. Add those up, and again, we're talking sum. So 3x plus 6 equals 117. Reverse PEMDAS, subtract 6 across, and divide by 3, and I get 30, 20, 37. Okay, so that works out nicely. You should get an integer like this. So I have 37. 37 plus 2 is 39. And add 2 more to that, 41. If I add all those together, I get 117. And there you go. Okay, let's look on the back side here. I'll do one more here. Let's go ahead and do one with a decimal. I talked about doing a decimal. Let's look at this one right here. So notice I have decimals in it here. So I could multiply the whole thing by 10. That would get rid of this decimal here, but it wouldn't get rid of them on this side here right now. So let's distribute the -4 through there. Then we'll clear the decimals. I multiply by 10. So I have 4.2z equals -2.4z minus 4.8. Okay, notice they all have decimals in them. I'm going to multiply the whole thing by 10. I move the decimal one to the right, right? So now I have 42z equals -24z minus 48. Okay, now I'm back to all integers. Remember, I take the smaller integer over to the bigger integer side. So I'm going to add 24z across, which gives me 66z equals -48. Okay, and the last step is to divide by 66. Well, then I have to reduce. So z equals, okay, you divide each by 2, -24 over 33. Okay, now I can see that 3 goes into both of those. Reduce again, or simplify, -8 11ths. That does not simplify or reduce anymore. So the answer is -8 11ths. So that one, since I didn't reduce with the greatest common factor, GCF, to begin with, it took me 2 reducings or 2 simplifyings. Notice the first one divided by 2, second 3. That means 2 times 3 is 6. I could have divided by 6 right away. If I would have divided by 6 right away, because that's a GCF, I would have got right to -8 11ths. Okay, but I showed you you don't have to as long as you reduce correctly. Let's do one of these and we'll be done. Okay, let's say 20. Twice the greater of 2 consecutive odd integers. Okay, 2 consecutive odd integers would be that right there. Twice the greater of the 2. So take that. Twice the greater of the 2. Odd integers. So I have 2 times the quantity x plus 2 is 13 less than 3 times the lesser. 3 times the lesser is 3x and it's 13 less than. That means minus 13. So there's our equation right there. Find the integers. Distributive property, 2x plus 4 equals 3x minus 13. Smaller one over the bigger side. That gives me x. That means I'm adding the constant across. 13 plus 4 is 17. So 17 to be the first one. And 19 the second. Okay, now let's check it. Twice the greater of the 2. 2 times 19 is 38. It's saying that that number should equal 3 times the smaller. 3 times 17 is 51 minus 13. 51 minus 13 is 38. Okay, so that's our check on that to guarantee that we had it right. So the two numbers are 17 and 19. And that'll end it right there.